Dear learners, this session we are going to see how we can able to combine all the scheduling algorithms in a single application in a CloudSim environment. So previously we have been seeing an outline of a round robin scheduler. Then we have been seeing how we can able to implement a first come first served scheduling algorithm. This code is going to have a combination of all the scheduling algorithms. So prior to the module, we are going to have the necessary libraries to be adopted. So here we have been imported from the org.cloudbus.cloudsim all the classes, and the specific is going to be the core cloudsim and the provisioners which we have been adapted. We are going to use the timestamp value from the Java util package from the calendar class using get instance method. Okay, moving on to the module, we have the combined scheduling Java class, and we have been used the various scheduling algorithms. You can able to replace it instead of shortest job first, you can able to replace it with first come first serve or round robin, or you can also specify your own scheduling logic also. Okay, you're just going to assign it as a parameter, and this is by default. You are supposed to have the initiation part using three parameters: number of users, calendar, trace flag. These parameters will be passed to the init method of your CloudSim environment to have the initiation to be taken up. Once initiation have been done, you can able to have your infrastructure to be laid out. In terms of your data center, you are going to create a data center in terms of the name, data center 0. You can also specify your own name of it. So once it has been called, you are going to have your own data center to be invoked. So you have your host list as well as processing element list. So for having your processing element list, we're just going to add the ID 0, and we have the processing element provisioner simple is going to be the instruction per second is going to be 1000. This is going to be one core. This acts as a one core, and you are going to build a host for it. You are just going to add a host to it. So the host to be added is host here ID is going to be 0, and we have RAM provisioner simple is going to be 2048, and the bandwidth provisioner simple is going to be 10,000, and we have the storage of 1 terabyte, the processing element list, and we are providing the scheduler policy, VM scheduler policy to be the time shared to be adapted for the processing element list. For this single core, we are configuring the server part of it. We are adding that host information to the host list. Not only this, we are just going to have the data center characteristics also to be equipped with. So we are going to have the name, and also we are specifying the data center characteristics that are equipped with a configuration, and we are going to have the VM allocation policy to be made simple for that specific host list, and adapting the linked list information for the host which you are going to add it one by one, then goes to the scheduling interval parameter which is going to be 0. So this module clearly identify the processing element as well as the host list configuration that have to be made to the data center. So once you have been created a data center, you can able to create a broker. Okay, using new data center broker name will be passed to it, and you can able to get the ID to it, generate the ID and save it as a integer variable. You can able to create your VM instances. Okay, in this code we are going to have an homogeneous virtual machine instances that have been created. ID is 1, I which has been incremented on its looping. Okay, broker ID will be generated by this, and the instructions per second is going to be 1000. Number of processing elements is going to be 1. The RAM usage is going to be 1024 bytes. Bandwidth is going to be 1000, and the size of 10,000 byte. And virtual machine monitor is going to be sent, and we are going to adopt the cloudlet scheduler policy is going to be time shared. So these are the parameters where we are going to pass it to your virtual machine, and you are going to add it to a VM list, virtual machine list. So once you have been generated all the virtual machines, you can able to submit it to the broker. Okay, using broker.submit VM list, passing the list to it. Then you are going to create the instances. Not the instances, here we are going to create the user task. So here making use of user task of 4 length has been specified. So 4 heterogeneous configuration has been figured out for your user task. adapting for the cloudlet method, invoking the cloudlet method, passing the ID. So ID is high. So as on looping, it is going to be incremented. The length is going to be taken up for in heterogeneous manner, and processing element, number of processing element is going to be 1, and the file size is going to be 300, and the cloudlet output size is also going to be 300. We are going to equip with the full utilization model of CPU, RAM, as well as your storage, okay, bandwidth. So all these configured for the specific user task. So user ID, you are going to get it with the broker ID, assign it to the cloudlet, and this cloudlet is going to be taken up to the cloudlet list. So you're just going to have the overall cloudlet list and adding all these informations, okay, related to the cloudlet instance. So once you have been add the user task has been configured, you are just going to apply the algorithm for the user task, right? So as you are going to have it using switch case method, you are going to have first come first serve. So this is where you have adapted a generalized view for the first come first serve. You're going to have the virtual machine list that have to be taken up. Using the virtual machine list, what are the tasks that has been taken up by the virtual machines? We are just going to identify get ID. Using get ID, we are going to set that particular virtual machine ID and assign it to the cloudlet list. So as of task has been assigned to the virtual machine, we are just going to equip it. Okay, this is a generalized way to represent it. The other part, when you're going to adopt the round robin way, you're just going to get the round robin index. Round robin index is, so if one task has been utilized by the processing element, the other task to be taken up by the next processing element. So we are making it to use it as a generalized way. We are adapting this round robin index, calculating this and passing it to the virtual machine list. So this can able to have the round robin, the time slice manner to have the resources to be allocated for a cloudlet, the user task. This is the second way. The third way is you are just going to have the shortest job first. By the name itself says that you are going to find the shortest part of it. So sort it by making use of the comparator for this particular cloud length. Okay, once you have been sorted, this cloudlet is going to have the sorted order of information of cloudlet. Once you have been found out, you are just going to pass it, getting the shortest job first index, passing it to the cloudlet. Okay, so you are just going to utilize it for the subsequent process also. You are going to apply this for a next user task also. So these are the various algorithm you have been adapted. If you have your own algorithm, you can also state it here in a default state, or else have the notification to the user perspective. Once you have been configured with a user task, you can able to go in for the submitting of cloud list to the broker. Using broker.submit cloud list, the cloud list have to be passed. So this is a complete configuration of your infrastructure with broker integrated. Then we are supposed to start the simulation. So it is going to be an automated process, starting with the cloud simulation initialization part, deployment of a data center, broker, virtual machines, then user task. The user task have to be accompanied with the scheduling algorithm what we have been used. Okay, so all those results can able to be identified using get cloudlet received list. This is going to produce the result list, and once all the job has been done, you can able to have the stop simulation for that CloudSim environment. You can also interpret the results using print cloudlet result method, passing the result set list of it. So this going to invoke this, just going to get the resource ID, resource virtual getting virtual machine ID, getting the actual CPU time, getting the execution start time, getting the finish time. So all those has been taken up as from the results that has been produced from the cloudlet. Okay, we're just going to run this code. So you will be finding out the configurations has been figured out and the various times that are evaluated with the broker stage, and we have been seen the various cloudlets, the user task that has been accompanied to the broker. Okay, and upon finalizing, we see that the resources have been shut down and the simulation has been completed, notifications. And this is the output interpretation of it. We have seen the cloudlet ID of 2 and 3 and 2 of status success, and the data center ID is going to be 2, with the virtual machine ID is going to be 0. We have been equipped with the start time is going to be 20, and utilization of this particular task is going to be 0.1, and the finish time is going to be 20.1. So this interprets that what is the time, how much time that a single user task has been accompanied, and how the cloudlet ID have been synthesized over to the data center. Okay. So you can also change for the various scheduling aspect. You can also check with your first come first serve, or you can also change with your round robin scheduling also. So with this, you can able to have a clear-cut deployment of your scheduling algorithm in your CloudSim environment. Thank you.